Good afternoon, everyone. Welcome to this Foundation Engineering course, which is conducted by Nptel. And my name is Rajat Boni. I am one of the PMRF research scholar at IITSM Dhanbad and also a teaching assistant of this Foundation Engineering course, which is conducted by Professor Dilip Kumar Vaidya sir. Today is week 7 of this course, and I have also 6 months experience on NPTL, teaching experience as assistant, and on NPTL, my previous course was Crown Improvement, which also conducted by Professor Dilip Kumar Vaidya sir. So today we are in week 7 of our lectures, Foundation Engineering lectures, and here we going to discuss the art pressure and retaining wall elaborately and try to solve assignment problems and class uh, unsolved problems also. Uh, uh, and one or two point I am mentioning here that these sessions are recorded and it will be uploaded after the meeting to my YouTube channel, and you can access it through NPTL. And also, whatever I am discussing here, the materials which I am going to discuss here, uh, everything will be shared to my Google Drive. You can access it from there. And one thing that if anything happens, that means network issue is happened or network line is cut, don't worry. I will try to join very quickly or try to solve these problems very quickly and join the meeting again. So let's start our today's session. In this session, we first go through one by one the class problems. Mostly this week are belongs to uh, solving the art pressure returning on problems, and there is limited theory on there, but we solve too many problems on art pressure and retaining wall based on the previous class theories. After that, we try to solve the assignment problem, or I think it can be first to solve assignment problem and then try to solve class problem also. So let's start our today's session. So it is already 4:10. So one by one, I go by these lectures. So I am sharing my screen. Please wait. I think it is visible. I am doing little adjustment. Please wait. I think it is now okay. So let's start our session. So we are in week 7, lecture number 31. So in lecture number 31 or 31 to 35 is belongs to the previous week lectures. That means week 6 lectures, and we it is the extension of the week 6 theories. That means art pressure and retaining wall. In week 6, we're going through three different types of art pressure. One is art pressure at rest, art pressure, active art pressure, and passive art pressure. Then try to define their formulas and earth pressure coefficient. So now, and also try to derive the thrust which is given by the soil, which is on the wall or retaining wall. And now it is in the week 7 is the extension version of the earth pressure and retaining theories. In week 7, lecture number 31, it is the extension of the week 6 class. In week 6, we deal with the cohesionless soil only. That means our backfill material, that is the wall, this retaining wall, which is uh, in the back side of the retaining wall, the soil is only a cohesionless soil. But in today's class, we deal with the cohesive or cohesion plus cohesionless C5 soil. That means in this soil, internal friction of the uh, in internal friction is also present, soil particle, and also cohesion also present. So how we deal with this type of soil in earth pressure retaining wall, and what are the changes in our earth pressure theories, formulas we can now see. So you see that our in C5 soil there there is always cohesion is present. So if we plot more circle diagram, the diagram should be drawn like this. In cohesionless soil, this failure zone or this failure surface start with from the origin like this. But in C5 soil, they are already present one strength, shear strength in terms of cohesion. So it cannot be zero at origin. So there always some strength remains in C5 soil in terms of cohesion. Or if we draw more circle diagram, it it there is a the failure surface is start with after uh, coming with after going with the cohesion. So this more circle diagram is looking like that. So where our sigma 3 is minor principal stress, sigma 1 the major principal stress, and the failure surface uh, give the failure strength is C plus sigma 10 phi, and phi is the angle of internal friction of the soil. It means particle to particle friction angle. So if we now we derive the formula from this we derive the formula for active earth pressure from this Mohr circle diagram, considering the failure surface. So we know that the sin phi, the maximum tangent, the tangent which is drawn for the maximum strength up to fails, it is equal to sigma 1 minus sigma 3 divided by 2. That means this angle is phi, and it is making a tangent with this circle. So this angle is 90 degree. So sin phi is equal to this by this. This means from here to here it is perpendicular distance. Here to here is opposite. So this distance is sin phi is equal to here to here it is sigma 1 minus sigma 3 divided by 2. Here to here it is cot c cot phi plus sigma 1 plus sigma 3 divided by 2. If you solve or rearrange this, we can get our sigma 3 because we need to find sigma 3 here. Sigma 3 is the horizontal pressure because in active case sigma 1 it is sigma v vertical stress is greater than horizontal stress because the coefficient of active pressure Ka is less than always less than 1. So sigma 3 is equal to the horizontal stress and sigma 1 is become vertical stress. So we have to find out sigma 3. So sigma 3 is equal to the sigma 1 K minus 2C root over K. So in if you remember our previous class where quotientless we will deal with the quotientless soil, we can get sigma 3 is equal to Ka sigma 1. There is no cohesion, so this term become cancelled. If cohesion is present, so it is become extra term is coming, which is reducing the value in term reducing the active earth pressure. If cohesion present, that is minus 2c root over k. But in passive case, it is become additive nature and it increase the passive pressure of the uh, passive earth pressure if cohesion is present. So in passive case, the pressure is increased if cohesion is present, but in active case, the pressure is reduced if cohesion is present. This formula also derived in similar way, the Morse by Morse circle concept. We can go through it. Then, if you draw the pressure diagram for active case, this is active pressure case. This is passive case. The diagram is looking like that. For if you consider that for active case, sigma k sigma v k a minus 2c root over k. If you plot this equation with respect to z, that means the depth from 0 to up to a certain depth z, then this diagram becomes like that pressure diagram. At the surface, that is z is equal to 0, sigma v is equal to 0, so it is become minus 2c root over k. After increasing the depth, this pressure diagram gradually increase and at the bottom the pressure is if the height if at the bottom of the wall if the height of the wall is h, this become gamma h k minus 2c root over k. Sigma v we know that gamma into z, so if you put h in place of z, then it is become gamma h k minus 2c root over k. But it is different in case of passive case. At passive case, so in active case, it is creating negative impact on the uh, active earth pressure, but in passive case, it is in additive nature. So at the top of the or at the surface of the wall, if in passive case, there is present. That means if you write sigma v into kp plus 2c root over kp, then it is and put z is equal to 0, it is become that means sigma v is equal to 0 in case of passive earth pressure. So it is become 2c root over kp. So there is present kp in the same direction of the sigma v. So the pressure diagram is looking like that, and if you gradually increase the depth, at the bottom of the wall, the pressure is sigma gamma h kp plus 2c root over kp. So it is very important these diagrams to find out the total thrust acting on the wall in case of either in case of active case or in case of passive case, because the area of this, if you calculate the area of this pressure diagram from here to here or here to here, we get the total thrust acting on the wall. And also if we find the CG of this pressure diagram, then we can get the point of action uh, on the wall, point of action of this thrust on the wall in different cases. So this diagram is very important to solve the problems. Then in active case, we know that at the top of the surface there is a negative pressure present due to the presence of cohesion. So this cohesion is tried to uh, because this cohesion is act in opposite direction of this uh, active pressure, which is occur due to the internal friction of the soil. So, so there may be happening crack due to the tension at the upper zone, because this cohesion act as a tension in this upper zone. So from here to here, where the at the top the pressure is minus 2c root over k, to the at a distance where the pressure becomes zero, if you gradually increase the depth, then up to this height is known as the tension crack zone, because up there is possibility to crack, possible crack due to the presence of the cohesion. So if we put sigma h, we know the sigma h at any depth is equal to sigma v ka minus 2c root over k, or sigma v, if you again write sigma z, gamma z k minus 2c root over k. So if uh, we know that at a distance where the stress is zero, this distance from the surface, this distance is known as a crack zone. So we conduct, or we put sigma h is equal to 0. So this is equal to, if you put sigma h is equal to 0, we can easily find the tension crack zone up from the surface. So it is become 0. So it is equal to z replaced by the ht, the depth of tension crack from the surface. Ka is equal to 2c root over k. If you solve it, it is become 2c divided by gamma root over k. So the tension crack from the surface to up to, from the surface is equal to the 2c, to 2 times of cohesion divided by the density of the soil into divided by the root over earth pressure coefficient in active case. So by this formula we can easily find out the tension crack zone for active case. But there is no tension crack in passive zone, because this cohesion is act in additive nature, in or we can say in the same direction of the passive pressure. So there is no possibility to create or difference in the stress. So there is no presence of the crack zone in active case, sorry, passive case. And this wall, if we excavate any C5 soil without any support, this we can excavate up to a depth of 2 times of HT. That means up to a depth of 2 times of tension crack zone, because this pressure from uh, from this point, the pressure above is cancelled out in same equal distance at the bottom. That means h into t. So from here to here, the distance is 2 times of ht. So for any soil, C5 soil, we can excavate without a support up to a depth of 2 times of ht. Now The same thing is derived here, so you can go through. So now there is one thing. If there is a presence of surcharge on the surface, ground surface, in the backfill, so the surcharge due to the surcharge also coming into the calculation to finding out the active earth pressure or passive earth pressure by multiplying the active earth pressure coefficient and passive earth pressure coefficient. But there is no variation in the this pressure because it is constant toward the depth uh, of the retaining wall. Then there is given the calculation to find out the um, uh, total thrust. So if for this type of problem and this type of problem, so you can see that here is the ground surface. We can neglect this part above the ground surface. So you only find out the pressure from here to here only. So you can see that if there is presence of external surcharge. So for the surcharge, one pressure diagram is coming, vertical pressure diagram is coming, that is Q, and if you multiply coefficient either K or Kp, it is become uh, horizontal earth pressure Qk, and due to the soil also, one earth pressure is coming, that is from top it is 0 and at bottom it is become gamma K into it. If we add both, then at the bottom it is become q qk plus gamma h k. At top it is q into k. So if you find out the area of this diagram, it will give the total thrust acting on this wall. And if you find out the CG of this pressure diagram, it is give the point of action of this thrust. Or we can divide the area for our comfort and it will give the same answer. Now we will move on to lecture number 32. And in from lecture number 32, there is so many problems regarding to this earth pressure and retaining wall stability. So one by one, we now try to solve these questions and also solve the previous year assignment problems. So I think it is better to solve the previous year assignment question first, because in previous year assignment question are in is very small, so it is very quickly we can done or solve it. So now I am moving to the previous year assignment questions. So first we try to solve the questions in 2020 assignments questions. So in 2020, we start with question number one, and don't worry, I also provide you the solution of this question in my handwritten notes. So don't worry, just look into this question one by one, and also I'm trying to solve here for your convenience. So sorry for that. So now we try to solve these questions. So with the first question is, with the increase in cohesion in soil, There is given four options. First option is decrease active pressure and increase passive resistance. Decrease both active pressure and passive resistance. Increase passive active pressure and decrease passive resistance, and increase both active pressure and passive pressure. So we know that, and also in just now is find try to divide these formulas for active case and passive case. So in active case, the formula active pressure formula is sigma H is equal to sigma V into active pressure coefficient minus 2C root over K. And for passive case, it is equal to sigma V into Kp minus plus 2C root over Kp. So you can see that by this formula, this coefficient uh, is increase the passive earth pressure. This is passive, this is active. Uh, Increase the passive earth pressure because it is in formula, it is in additive nature, but it is decrease the active earth pressure because in formula it is in negative sign. So our correct option is option A. The question, if you increase the question, it is decrease the active earth pressure, but it is increase the passive resistance. So I think it is understand to everyone. So now we move to uh, question number two. So in question number two, it is said that surcharge loading required. So I think question number one is understand to everyone. It is in passive case, it is decrease the active earth pressure. Sorry, the question is decrease the active earth pressure, and it is increase the passive earth pressure in if the question is increased. So it is. I think it is understand to everyone. I think so. So question number two, it is said that the surcharge loading required to be placed on the horizontal backfill of a smooth vertical retaining wall so as to completely eliminate tension crack is. So it is said that if we place surcharge loading at the top of the uh, horizontal backfill where a smooth vertical retaining wall is present, then what is the value of the surcharge to completely eliminate the tension crack? So if you see that the for active case the tension pressure diagram is like this. Here it is minus 2C root over Ka. Here it is uh, gamma into H Ka minus 2C root over K. If you apply surcharge also here, then surcharge become constant throughout the height, and it is become if you apply surcharge Q, and it is become Q into K, Q into K. So it is said that at the tension zone, so it is said that what is the value of this surcharge to completely eliminate this tension crack. So if we, that means this 2C into root over K is becomes equal to Q into K. if we completely eliminate this tension cake. So it is that means if we completely eliminate this tension cake, this equal should be equal to this one. That means surcharge earth pressure due to the surcharge is equal to the earth pressure due to the cohesion. So Ka Q into K is equal to 2C into K. If you cut here, it is become over K. So answer is Q is equal to 2C divided by over Ka. So our correct option is option D, that is 2C divided by root over K. So it is very simple to understand. That is just equal these two. That means earth pressure due to the surcharge, it is become QA, or earth pressure due to the cohesion at the top surface, it is equal to 2C root over into root over K. So it is cancelled. It is become 1 by root over K. Then it is coming out 2C by root over K. So answer is option D. Now I think it is understood to everyone. So now we move on to question number 3. So in question number 3, it is asked that the maximum depth of excavation in meter that can be made in a clay soil having C is equal to 60 kilonewton per meter square and phi is equal to 0 dB and gamma is 20 kilonewton per meter cube without any lateral support. So we also discussed this type of question in today's class also, in today's class in the to find out the tension crack zone. So we know that the maximum depth we can excavate in a C5 soil is without any lateral support is 4C divided by gamma into Ka. So find everything is given. We have to first find the Ka. K is active earth pressure coefficient. It is 1 minus sine phi divided by 1 plus sine phi. So here phi is equal to 0 degree. So it is become 1. So the so we put all this value 4 into 60 divided by gamma is here 20 into 1. So answer is 12 meter. So in this condition of soil, we can estimate maximum depth up to 12 meter. So our correct option is option B, that is 12 meter. I think it is fine to everyone. That is, if any type of soil, that is any type of C5 soil, the maximum depth we can excavate without any support, it is 4C by root over uh, K into gamma. Uh, or we can say 2 times of tension crack depth. I think it is understand to everyone. Now move on to question number 4. So in question number 4, it is said that if a uniform surcharge of 60 kN per meter square is placed on a backfill with phi is equal to 30 degree, the increase in active earth pressure is, that means uh, due to the surcharge, what is the increase active earth pressure in the uh, backfill. So first find out the active earth pressure coefficient. Here it is 1 minus sine phi divided by 1 plus sine phi. Uh, Phi is equal to 30 degrees, so it is become Or if we put 5 is equal to 30 degree, then it is become total K is become 1 by 3. We know that due to such charge, the active earth pressure at any depth is constant, and this become, if we put such as here Q, and active earth pressure is become Q into K here, also Q into K here. So the increase is Q into K. Here Q value is 60 and K is 1 by 3, so it is become 20. So the active earth pressure is increased 20 kilonewton per meter square. The correct option is option C, 20 kilonewton per meter square. It is fine to everyone to understand, I think. So move on to question number 5. It is very easy to solve every question. It is just little concept is there, or logical thinking are required to solve these questions. This question is very easy. This assignment question. So now we try to solve the question number 5. So in question number 5, it is said that an unsupported excavation is made to the maximum possible depth in a soil having gamma is equal to 17 kilonewton per meter cube, C is equal to 45 kilonewton per meter square, phi is equal to 30 degree. The active earth pressure, according to Rankine theory, at the base level of the excavation is, if the water table uh, effect is not considered. So we have to find out the active earth pressure due to the according to the Rankine theory at the base of the excavation. So we know we draw the active earth pressure diagram in C5 soil. It is looking like that. Here it is 2C over K, and here it is gamma into H into K minus 2C root over K. So we have to find out this pressure. That means gamma into H into K minus 2C root over K. So put all these value and we get the answer. So first we find out the K for 30 degree. K is equal to 1 by 3. We also this find out in the previous question also. And so put all this value. That means gamma here 17. K H is here the height of the wall. Here height. So there is one logic is required. First find out the height of the. So first find out the height of the excavation. So it is said that this excavation, the excavation for this unsupported is maximum. So we know that for maximum unsupported depth is equal to, for any excavation for C5 soil, is equal to 4C gamma divided by gamma into K. So it is the maximum height, and this height is the required to find out the stress or pressure at the bottom of this excavation level. So first find out the height, that is 4 into C is here 45 divided by gamma is here 17 and to root over 1 by 3. K is 1 by 3. So put all these value, 4 into 40 divided by 17 divided by root over 1 divided by 3. So the height is become 16.3. I think so. I looking look just look to the problem. Sorry, the height is become, I am again calculating, it is 45. Sorry for that. 4 into 45 divided by 17 divided by root over 1 divided by 3. So it is become 18.34. So our height is, excavation height is 18.34. Here to here it is 18.34. So put all this value. Now put h value here. So h is, find out 18.34. Then k we find out 1 by 3 minus 2 into 45 into root over k 1 by 3. K is 1 by 3. So answer is 17 into 18.34 into divided by 1 by into 1 by 3 minus 2 into 45 into root over 1 divided by 3. Answer is 51.96. So is this close to 51.9? So our correct option is, answer is 51.96 at the bottom. So our correct option is option B. So it is very little bit typical problem. So first, to solve this problem, so we need to tackle first statement, that is an unsupported excavation is made to the maximum possible depth. So we know that for unsupported maximum possible depth is 4c divided by gamma into root over k. So by this formula we find out the height of this excavation, and it is said that at the bottom of this excavation level, we find out the active earth pressure. So we know that active earth pressure at any depth is equal to, for C5 soil is equal to gamma into Z into Ka minus 2C root over K. So we put Z is equal to H. Here we find out H is equal to 18.34, and put all this value. K we find out 1 by 3, and it become 51.9 kilonewton per meter square at the bottom of the excavation level. So answer is option B. Now move on to question number 6. In question number 6, it is said that a retaining wall with a smooth vertical back retains a sand backfill for a depth of 5 meters. The backfill has a horizontal surface and has the following properties: C is equal to 0, phi is equal to 30 degrees, and gamma bulk is equal to 17 kN per meter cube. The backfill supports uniformly distributed load of 20 kN per meter square. The total active thrust in kilonewton per meter length. Use Rankine's theory. So this question little bit tough. Go by concept by go to the concept by concept. So first try to draw the pressure diagram for this condition. So it is said that a retaining wall with smooth vertical wall at a depth of 5 meter. So our retaining wall height is 5 meter. Here to here. Then it is said that phi is equal to 30 degrees. So due to the phi is 30 degree, we previously derived that K is equal to 1 by 3. Now gamma bulk is given 17 and C is equal to 0 degree. and also they said that there is acting uh, such as Q is equal to 20 kilonewton per meter square. So due to the such the pressure diagram becomes Q into Ka, and due to the soil, the pressure diagram becomes from here to here it is 0, here it is gamma K into H. So find out the total active thrust. That means to find out the area of this diagram and add it. So area 1 and area 2. The area 1 is Q into Ka into height of the wall H, and area 2 is half gamma area of the triangle, that is gamma Ka base into height H. So put and add it and put all this value. Q is 20, Q is a solving calculator. Q is 20, gamma K is 1 by 3, H is 5, gamma is plus half into gamma is 17, again divided by 1 by into 1 by 3 into 5 square, that is height square, and it is become 104.167. So our correct option is option D, that is 104 kilonewton per meter. So you got also remember the units also. So correct option is option D. Now move on to the question number 7. It is said that the total active thrust, which is also belongs to the question number 6, we find out the total active thrust if water table is present at a depth of 3 meter and there is no drainage. So due to the water table also there is a effect in the active thrust. So we modified our diagram. We again draw the pressure diagram. So for such as it is become same. It is Q into K. For soil, now it is divided in two layers. Layer 1 height is H1 is 3 meter from the surface and H2 is 5 meter below the surface. From surface above the layer 1, the pressure diagram means here to here is gamma Ka into H1, that is 3, and from here for layer 2 pressure diagram, here it is act as a surface. From here to here it is same, that is gamma Ka into H1. From here to here, due to the layer 2 soil condition, that is due to the presence of water table, gamma becomes gamma saturated submerged, it is gamma dash Ka into H2. Then due to the soil water also, we know that in Pascal law, water can act in three dimension. So it also act as a horizontal thrust. So due to the presence of water, water can add some force on this active thrust, and we know that water is present on the second layer. From here it is 0. It is gamma W. Unit of the water is gamma W into H2. So now we find out this area 1, area 2, area 3, area 4, area 5, and add it, and we get the answer. So it is from area 1 it is QA into K, area 2 is half gamma Ka into H1 square, area 2 is area 2 हो गया, area 3 is uh, gamma Ka H1 into H2, because gamma K H1 is act as a surcharge in this layer, and if you multiply it into H height, it will be, we find out the area of this pressure diagram plus half area 4 gamma k a gamma dash k a h2 square. And last for water it is gamma half gamma w h2 square. So put all these value where gamma dash is gamma saturated or gamma bulk minus gamma w, and put all this value and find the answer. So 20 into Q is 20 into 1 by 3 plus zero point 0.5 into gamma is here from 6 here it is 17 into point 1 by 3 into 3 square plus again 17 into 1 by 3 into 3 into 5 plus zero point 0.5 into gamma sum much is 17 minus 9 so here it is given 10 10 into 0.33 into 5 square plus zero point 0.5 for water into 10 into 5 square. So answer is 2. The answer is k into h. It is h. Here it is h. Total height is again I'm doing it and there is something going wrong into 8 plus total height is become sorry I'm doing mistake. It is 3 and it is 2 because total height is here 5. So I'm doing again 5 into 17 into anything into 3 square plus 7 into 3 into 17 into 3 into 2 plus 5 into 7 into 17. Answer is 116.525. So the closest answer for this it is coming out 116.525. So the closest answer or closest option for this answer is 119.5. So the correct option is option A for this problem. I think it is understand to everyone. So first we do for divide the pressure diagram in for different time items. For such as there is one pressure diagram, active earth pressure diagram for and due to the water table presence, the layer also divided. The upper layer there is one pressure diagram. Below the water table there is one pressure diagram, and also there is a one pressure is add due to the presence of the water table because the hydrostatic pressure also act as a in horizontal direction in, by the law of Pascal. Now I think it is understand to everyone, and this I am also solved this question in my handwritten notes. You can go through it if you have any doubt, and also prefer my video lectures in the later period. You can go through it. So now we move on to the question number 8. So in question number 8, it is regarding the Passive earth pressure. You're going to find out the passive earth pressure thrust. Passive thrust. So it is said that. So just 1 minute, 1 second. We are discussing the question number 8. Now, question number 8. It is said that an earth retaining wall 4 meter height. The height of the wall is 4 meter. Support a backfill with the horizontal top. So top surface is horizontal. The wall pushed toward the field. So we know that if the wall push towards the field by this soil below the retaining wall, then it is there is a presence of the passive earth pressure. So this problem is regarding to the passive earth pressure. The total force on the wall just before the failure. So we have to find out just before the failure of the what is the pressure on this one. That means we have to find out the total passive thrust on the soil. And soil properties is given, that is C cohesion given 20 kilometer per meter square, phi is given 30, and gamma is given 20 kilonewton per meter cube. So for C5 soil in passive case, the pressure diagram is become like this. Above it is 2c root over kp, and below it is from here to here it is same 2c root over kp, and here it is gamma h into kp. So you divide this area, find out area of this diagram, find out area of this diagram. So it is become, if height of the wall is h, first find out the kp. So for 30 degree, we know that k is 1 by 3, and we also know that kp is equal to 1 by k, so it is become 3. And for this area, for this diagram, the area is 2c root over k p, so kp into h, height of the wall. Now, and also there is no presence of water table, so it is okay. And it is become, and for this diagram, area of 2, it is area 1, area 2, so it is become half gamma h square into kp. So put all this value, that is 2c is 2 into 20. I'm writing solving in calculator, 2 into 20. What 20 is the question into root over 3. 3 is the kp coefficient. Height is 4, so height is 4 meter, plus zero point 0.5 into gamma is given 20 again, and it is 4 square is 4 square, and kp is, answer is 5757. So correct option is option number C, that is 757.12. So option is correct option is option C. I think it is understand to everyone how it is solving. Just draw the pressure diagram for this case and divide this pressure diagram as your suitable known area. That is, I am dividing it in a rectangular and triangle. We can also solve this is by directly by considering this diagram as a trapezoidal, and uh, and put the trapezoidal equation, that is half into height of this trapezoidal into a plus b. It is, if you consider this surface is a and from here to here it is b, then you can easily solve directly also, or for you convenience and easy way, I think it is better to divide this area pressure diagram, and you can easily find out my basic area formula. Now we move on to question number 9. So there is 12 question there. I think now we can take one small break. After that, we can start again. So please wait on the line. Before starting the question number 9, we can take one small break of 5 minutes. So I am coming back after 5 minutes. Please stay on the line. Now, welcome back to this session again. This is week 7 foundation engineering class. So we are discussing the assignment problems, and we are on question number 9. Up to question number 8, we solve all this problem. So move on to question number 9. So in question number 9, it is said that a retaining wall of 10-meter high with smooth vertical back and retains the backfill with 30 kilonewton per meter square, and 15 degree is the phi, and gamma is 17 kilonewton per meter cube, gamma set is 20 kilonewton per meter. The total Rankine active thrust on the wall after the formation of the tension crack. So first draw the pressure diagram. For cohesive C5 soil or cohesion added soil, the pressure diagram for active thrust is here it is 2C root over Ka, here it is gamma H, height of the wall, into Ka minus 2C root over Ka. So it is said that after formation of the tension crack, what is the uh, what is the active total active thrust? So we have to reject from here to here pressure diagram. This it is not coming in the calculation because it is said that after formation of the tension crack, what is the total thrust? So first we find out the height of the tension crack. So we know that height of the tension cake HT is equal to 2C root over gamma divided by root over K into gamma. First find out the K. For K is of sine 15 degree is equal to 1 minus sine 15 degree divided by 1 plus sine 15 degree, and it is become 0.59. So we put here 2 into C is here 20, the 30, 2 into 30 divided by gamma is here given gamma only because there is it is not said that there is a presence of water table, so we cannot use the gamma saturated value here. So we use gamma is 17 divided by over k. K is we find out 0.59. So height of the tension curve is become 4.6. So after finding the 4.6, so this distance become h minus ht. So here ht is 4.6, h is here 10 meter. So now find out the area of this triangle, and it is become half into base is here gamma into h into ka minus 2c root over ka whole into height from here to here, that is h minus ht, and it is coming out, and I am writing here 0.5 into gamma is 17 into h is 10 into ka, so k is 0.59 minus 2 into 30, 30 is c into root over k is 0.59 again, and into 10 minus ht is 4.6, and it is coming about 146.375. So the closest answer is option C, 146.63. So correct option is option C. I think it is understand. It is said that find out the active thrust after formation of the tension crank. So we neglect the upper portion or stress up to tension crank, and then calculate the active thrust below the tension crank. Now I think it is understand to everyone. It is a little bit difficult problem. I think it is understand to everyone. I am so move on to question number 10. In question number 10, it is said that a retaining wall of 10-meter height with a smooth vertical back fill vertical back and retains a backfill of which C is 30 kilometer per meter square, phi is 30 degree, gamma is 70 kilometer per meter cube. The horizontal soil surface carries a uniform pressure is 40 kilometer per meter square and total Rankine passive thrust. So it is find out the total Rankine passive thrust soil condition I am retaining here. Our diagram, it is retaining wall is height is 10 meter and gamma is here 17 kilometer per meter cube, and surface is acting also present, there is presence of C, that is cohesion. So pressure diagram become for surcharge it is like that, Q into Kp, and for C5 pressure diagram become for passive case like that. Here it is 2C into root over Kp, and here it is same 2C root over Kp, and here it is gamma H Kp. To find out this area, this area, this area, and add up. So First find out the Kp. We know that for 30 degree Kp is equal to 3. We previously defined, and put and find out area one by one. First area one is Q into Kp into h, height of the wall, plus 2c area 2 root over Kp into h, height of the wall, plus half comma Kp into h square. Put all these value in this equation. It is Q is here 40, Kp is 3, height is 10, plus 2 into C is here 30 into root over Kp is 3 into height is 10 again, plus 0.5, which is half, into gamma is 17 into Kp is 3 into height is 10 square. So it is become 4789.23. So correct option is, or similar option is, option A, that is 4789. So our correct option is option A. Option A. You can see that the correct option is option A. Now move on to, I think it is understand, it is very simple. So if you understand this problem, it is very easy to understand question number 11, which is belong also required the data of question number 10. So it is said that try to find the point of action of this passive thrust from the base. We have to find out the point of thrust from the passive thrust from the base. So we know that this pressure diagram first is here. Again I am doing Kp. Here it is 2c root over Kp, and here it is gamma h Kp. So we know that for this diagram, the CG is belongs to here at the middle of this diagram also at the middle, that is h by 2, height of the half height with the height of the wall, and from bottom here it is h by 3. So to find out the CG of any area, any particular combining area, that is 1, 2, 3, it is equal to y bar is equal to p1 y1 plus p2 y2 plus p3 y3 divided by total force P. So we find out P1 is Q into Kp into H, and height CG is H by 2, and then P2 is 2C root over Kp into H, and also CG is Y2 is H by 2. Then last one is very typical. Area is half gamma h square into Kp into CG is h by 3. So put all these value, and total is 4. So you also find out the 4789. This will P is 4789, and find out, put all this value and find out. So it is become 20, Q is, sorry, Q is 40, 40 into 3 into 10 into h by 2 is 5, plus 2 into c is here 30, 30 into root over 3 into 10 into 5, 5 plus 0.5 into 17 into gamma is 17, 17 into 100, that is 10 square, into Kp is 3 into h by 3, this is 5 divided by 3, and divided by total force is 4789. and it has become 3.3, then it is from the, sorry, sorry, into 8 minus 5.2, 10 divided by 4789. Yes, it is become 4.11 meter. So the correct option is option C, that is 4.11 meter. So option C is correct for this question. So just doing first find out the area, total area. Then after finding out the total area, divide this area and individual area also found, and for individual areas, individual CG also found. After this area is P1, this area is P2, this area is P3, and Y1 is CG of this area, Y2 is CG of this area, Y3 is CG of this area from the base. And use this formula P1 Y1 plus P2 Y2 plus plus total force P of total area, and find out this. Now we moving to question number 12. The question number 12, it is said that a homogeneous gravity retaining wall uh, supporting a cohesionless backfill is shown in the figure. The lateral active earth pressure at the bottom of the wall is uh, at the bottom of the wall is 60 kPa. So find out. So the minimum weight of the wall is required to prevent its overturning about this two. So we have to know that this is toe, this is heel. You have to remember it. This is toe. If you draw a foot like this, we know that this is toe, this is heel. So like this returning wall, this is toe, which is air from the backfill, and towards the backfill, this is heel. So we have to find out the overturning weight, which is we have to find out the weight of the wall, which is required to prevent the overturning, which are respect to this toe P. So first, draw the pressure diagram. So pressure diagram is given from questionless way. At top it is given 0, you know, but at the bottom it is given 60 kPa. So the total area of this pressure diagram is, or total force of this pressure diagram is half into 60 into height of the wall is 6 meter into K. Sorry, lateral earth is also given, so half into 60 into 6. So no need to multiply the K because it already multiplied and given the answer 60. So it is become half into 60 into 6, it's become 30, 30 into 20 into 60 into 6. 180. So total force active thrust is 180. We know that this active thrust act from the bottom of the wall at a height h by 3. The point of action on the bottom is h by 3. If we draw properly here, this is the wall and the P is acting at a height h by 3 from the bottom, PA, total active thrust, and this is the h by 3. And also we know that the weight of the wall is go to the CG from the CG, and it is divide the wall here h by 2, here h by 2, sorry, h by not h by 2, it is the length, width we can say. L, if it is called L, total length, and it is divide, why it is divide this length by L by 2, L by 2 in equal parts. Now we know that in overturning moment, uh, to prevent the overturning moment, we apply the resisting moment in terms of weight with respect to the point P here. So just equating the moments. So overturning moment is PA in terms of active thrust into and arm lever arm is h by 3, and resisting moment is W into weight of the wall into L by 2. Just equating and find out the W, total weight required to prevent the overturning. We find out PA is 180, H by 3 is 6 by 3, and divided by L by 2 means 4 by 2, and find out the W, and it is 2. This is also 2, 2 cancel again, and it is become 180. W is equal to 180. The correct option is here option B. Total weight is also equal to the total active artificial thrust, and the correct option is option B. So I think we solve all these assignment problems. And these assignment problems is as equal important to your class problems, and it is very good. There is very good assignment problems given in previous year, and I think this all are also there is similar types of assignment problems are given. And if you go through this previous year assignment problems, I think you can easily solve this year assignment problems. And I'm also sharing you 2023 assignment problem solutions with assignment problems questions. You can go through it also. I think there is no need to doing extra things if you do these assignment problems. And now we try to solve the class problems, which is discussing in the class. And there is very big problem and good problem given or discussing in class by the sir, Dilip sir. So now I am moving discussing one by one these class problems, and if time permits, I probably solve all this problem. If not, I will share you the solutions of these class problems. You can go through it. So going to the assignment problems, sorry, class problems. So now you again go to the class problems. So please give me one sec. Now we're trying to solve these class problems. I think I am audible now. Hello, hello. I think I'm audible. So now I'm solving the class problems one by one. Hello, hello. So starting with the lecture number uh, 32, first problem. They said that a retaining wall, a smooth back, vertical back of 8 meter high and retains the question in soil backfill, that is C is equal to 0, and depth of the water table from the surface is given 3 meter. To calculate the total active thrust on the wall and its point of application on the base. The wall retains the horizontal cohesionless soil backfill with the angle of internal friction Phi is equal to 35 degrees. Then and the total unit weight of the soil is given 18 kilometer per meter cube above the and below the water table. So I am drawing a condition of the soil given problem. 8 meter height water table, 8 meter height wall is given, and water table is at a distance of 3 meter. Here is 3, here is 5, and it is said there the phi is given 35 degree and gamma is given 18 kilometer per meter cube. So I'm moving to my solution page. You cooperate with me. I think yes, this is the solution. So the first we find out the K for 35 degree. The K for the 35 degree is 22.27 uh, 0.27 and gamma is 18 and gamma W is 9.81. Then similar type of problem I'm also solving in previous class and this class also. So first divide the area 1 and area 2, and area 3 is for water. So from here to here one soil condition, from here to here another soil condition because it is below the water table. So the total force active thrust is the summation of these areas. So that is first is half gamma h1 square k. K is the active earth pressure coefficient. Then area 2 is I am considering it is a trapezoidal. So from this surface and this surface, so here it is 2 into, that is if you add this one, it is become 2 into gamma h1k plus gamma dash h2k. So into height is height is h2 plus half gamma w h1 h2 square. So put all this value here. H1 is 3, H2 is 5, gamma W everything, and the total force you can find out is 245.04 kilometer per meter. So from to find out the point of action, we again applying this formula, that is P1 P2 P1 Y1 plus P2 Y2 plus P3 Y3 divided by P1 plus P2 plus P3. P1 is nothing but the area of this pressure diagram, that is total thrust of each pressure diagram, and Y1 is the point of action of this pressure force from the surface. So from the surface, if you again put P1 is half gamma H1 square into K, and from the surface Y1 is 2/3 of H1, and from the Then from area 2, we again apply the trapezoidal area, and to find out the y2, we use trapezoidal formula from surface. From here to here it is h1, and we then plus from here to here it is CG of this area. So CG of this area for trapezoidal we know that h by 3 into 2a plus 2b, a plus 2b divided by a plus b to find out the CG of the trapezoidal. A is the near surface, near width. B is the wider or far width. It is B. It is A. If you consider, we find out the H or Y1 from this surface. So again, if you put it is B, it is A. Put that is twice A plus twice B. It is become 3H1S. 1 gamma Ka plus 2 gamma dash is to K, and we have A plus B, then it is become 2H1 gamma Ka plus gamma dash Ka H2. Then from here to here it is H1, from here to here it is 2H3 H2 for this diagram, and area of this diagram is half gamma WH2 square. Put all this value and divide by the total area, that is nothing but the total force, and get the answer is 5.7 from above the surface, from the surface. So if you find out this point of action from the base, then it is we would subtract this value from the total height of the wall, that is h minus 5.7, and it is become 2.3. So correct answer is, our answer is, for total thrust is for the first question the total thrust is 240 point, 245.04 kilometer per meter, and this is wrong. I cannot follow. And it is become and the CG from the base is become 2.3 meter. Answer. Hmm. I can just. So now move on to the question number 2 of the lecture number 32. So I think first question is understand to everyone. In lecture number 32, there is two types of. So in lecture number 32, it is said that the retaining wall is height is given 8 meter high. Two layer soil is given from 0 to 4, and that is C and phi is 30 degree and gamma is 18 kilonewton per meter cube. From 4 to 8 is given, C is given 0. Again phi is 35 degree and gamma is given 19 kilonewton per meter cube. So first draw this pressure diagram and try to solve it. So here to here the pressure diagram is gamma Ka1 for first layer H1. Yeah. Then here it is changed. Again the pressure there is gamma Ka2 is H1. From here to here it is become 0. It is same and it is gamma Ka2 H2. So to solve this, find out first each layer K1, K2. The first layer K1 is for 30 degree, it is 0.33, for 35 degree 0.27. So 0.33 is the first one K and first second one is 0.27. Now it is area 1, it is area 2, it is area 3. The area of the first layer is from the half P1, you can say gamma, sorry, gamma 1, it is gamma 1, it is gamma 2, Ka1 into H1 square. It is become 0.5 into gamma 1 is 18 into K is K1 is for 30 degree 0.33 into H1 is 4 square. It is become 47.5. Y1 for first layer is from here to here is H2 plus H1 by 3. So it is 4 plus 4 by 3 and it is become 5.33. Then P2, P2 is acting as a surcharge, that is gamma 1 Ka2 H1 into H2. So it is become gamma 1 is 18 into H1 is 4, H2 also 4 into K2 is 0.27. It is become 77.76 and Y2 is H by 2, that is nothing but 4 by 2 is 2. Then P3 is half gamma 2 Ka2 H2 square and it is become 0.5 into gamma 2 is 19 into a gamma 2 K2 is 0.27 in H2 is 4 square and it has become 41.04 and Y3 is become H by 3 H2 by 3 is 4 by 3 It is become 1.67. So, or sorry, 1.33. Now, total thrust is P1 plus P2 plus P3. So it is equal to 47.52 plus 77.76 plus 41.04, 166.32, and total y bar is P1 y1 plus P2 y2 plus P3 y3 divided by total force P. So it is become 47.52 into 5.33 plus 77.76 into 2 plus 1.33, 41.04 into 1.33 divided by total force 166.32, 2.78. Correct answer is 2.78, and total force is to 166.32. So this is the solution of the question number 2. This is wrong. Cannot follow this. Then it's also wrong. I'm doing here. You can see now question number third one. It is also cannot follow my solution. I am solving here in fresh way. So a retaining wall is given 6 meter height to thickness, two layers in thickness is each layer is 3 meter, and upper layer is phi is 30 degree, and lower layer phi is 18 degree, and gamma bulk and gamma given 18 kilometer per meter cube, and gamma situation is given 15 19 kilonewton per meter. So again, try to draw the pressure diagram. First, find out K1, K2. K1 is for 30 degree is 0.33. K2 is for 18 degrees become 0.53. After that, again try to draw the pressure diagram. From here to here, it is this one is gamma 1 K1 because C is 0, K2 and H1. It is equal to point. Gamma is first layer 18 into Ka2 is 0.33 into H2 is 3, become 17. Again I'm doing it. Gamma is 18 into H2 is 3 and divided by it is become 18. And for layer 2, from here to here distance is it is become gamma 1 Ka2, sorry here it is Ka1 not Ka2. First layer it is Ka1, Kh1, K2. For second layer it is K2 into H1 minus 2C over Ka2. So it is become 18 into Ka1 is Ka2 is 0.53 into H1 is 3 minus 2 into C is given 10 into root over 0.53. It is become 14.06. Then from here to here it is 0. Here to here it is 14.06 and this is gamma 2 K2 H2 minus 2C root over K8. Become 18. So gamma 2 is 19 into 0.53 into H2 is 3 minus 2 into 10 into root over 0.53. 15 point, sorry, the distance is that 15.65 and this gap is 2C 10 2C per Kf 2 is equal to 14.53. Now area 1, area 1, 2, 3. So P1 is gamma half uh, this 18 into 3. This become 27. And from the base it is y1 is 3 plus 3 by 3, that is 4. P2 is this area from here to here, it is 14.06 into the height is 3, and it is become 42.18, and y2 is h by 2, h2 by 2, that is 3 by 2, and it is become uh, 1.5 on the bottom. P3 is equal to this area, and it is become half into 14.53, 14.53 into sorry, plus 15.56 or 65, 15.65, I think, 15.65 into height of the height, that is 3. It has become 45.27, and y3 is h by 3, that is 3 by 3, become 1. Now find out total force P is equal to P1 plus P2 plus P3, that is 27 plus 42.18 plus 45.27. This become 114.45. Then Y bar is P1 plus P2 Y1 bar plus P2 by Y2 plus P3 by Y3 divided by P. It is become 27 into 4 plus 42.18 into 1.5 plus 45.27 into 1 divided by total force 114.45. It is become 1.89. So correct answer is 1.89. So you can go through it. Now mo- moving to the lecture number 33, and I think first, second question I am also already done in assignment problems. Just look into this problem and try to solve by yourself. It's very simple. I am just tell question number third one of the lecture number 33. That is, we need to find out the vertical. It is given the vertical cut of purely cohesive soil filled when the Depth of the cart reached to a depth of 5.1 meter, and gamma is the soil is given. So find out the cohesion. So we know that maximum depth for cohesive soil, pure cohesive soil, like H is equal to 4C divided by gamma. So put all these value. H is here 5.1, 4 into, we have to find out C, and gamma is given 20. So answer is 1 into 20 divided by 4, 25 point, C is equal to 25.5 kilonewton per meter square. So now I think if up to this is clear. Now move on to question number, lecture number 35. In lecture number 35 and 34, sorry, 34 and 35, there is two problem. There is two problem regarding the stability of the retaining wall. So these problems are little bit similar, and if you try, you can very easily solve. I am just discussing the theory of this problem, and I am following the book of Vajra Das, of Principle of Soil Mechanics and Foundation Engineering by Vajra Mohan Das. So I am quickly discussing the theory. You can look into this. So for stability of retaining wall, we have to need to check the overturning, also need to check the sliding, and also need to check the bearing capacity failure. So there is different for this. We need to check, calculate these forces and try to find the factor of safety regarding these failures. And most commonly, so here it is said that we have to need to check the overturn, also check the sliding, also check the bearing capacity failure, and also try to check the shear failure and check the excessive settlement. Most of the first three is doing in most of the case, that is overturning, sliding, and bearing capacity failure. And for this different type of, that means overturning means this type of failure, overturn, that means retaining wall due to the earth pressure, the retaining wall try to overturn. Sliding due to the less friction, retaining wall try to move away. And bearing capacity failure, that is if there is a uh, capacity of the below the retaining wall is less, it may be fail by any way. So we need to check everything. So first we check the overturning. So for overturning, we need to find the overturning moment, and for finding, before finding the overturning moment, so we have to follow this figure. So here we see that given all the forces of the retaining wall. So first this is cantilever retaining wall, and uh, this is the earth retaining wall, we can say. So we see that in cantilever retaining wall, if soil is present in this side, it is act as a passive force thrust. If soil is present this side, which is retained mainly used for retaining the backfill, then the pressure is act as a active thrust. And below the cantilever, we see that bearing capacity is acting. So if there is a asymmetry of the bearing capacity, then there may be possibility to create the maximum and minimum bearing capacity. Due to this maximum minimum capacity, tension zone is created if it is below the zero, or a negative stress is created, and which is very dangerous to fail the soil by bearing. And also there is a force act by the self weight of the retaining wall, and we find, after finding all these forces, we evaluate the different factor of safety. So first factor of safety is for overturning, that is overturning moment, resisting moment divided by overturning moment. And this overturning factor of safety should be the value. It is not given here, I think. Wait. Values are not given here. So I think overturning it is greater than 2 or 2.5. It is not given here. So first find out the overturning. So overturning is occurring due to the passive earth pressure or active earth pressure, and resisting moment is acting due to the self weight of the retaining wall. So first find out by this formula. I am sharing these theories to you. You can access it. Then after that, we find if satisfying the overturning, we have to find out the sliding. So again, sliding is also the resisting force divided by the sliding force. And sliding force is the that means driving force is occur at the bottom of the retaining wall due to the shear force at the bottom or friction force. If and again we have to satisfy this sliding, and after that at last we have to satisfy the bearing capacity failure to and find out the minimum and maximum bearing capacity at the base of the retaining wall, and try to find out the tension zone if or we can eccentricity or uh, if our eccentricity is within the b by 6 of the below the retaining wall, of the base of the retaining wall, then it is safe. We can say it is safe. So if E is greater than B by 6, there is no possibility to create the tension crack. So we need to check all this to find out the stability. And there is also one problem is given. You can go through it to finding solution. So I think you once go through it. Yes, overturning factor is greater than 2. Sliding factor is greater than 1.5. And also you have to need to check the bearing capacity failure. So I am providing you this solution and this theories. You can once go through it. It is very simple. Easily you can find out. Here it is required the active heart pressure formula and the self-weight formula and the moment equilibrium and vertical force equilibrium. You need to check. So now is time to stop here. So it is already 6:17. I am stopping here. We can meet again in the next week. That is week 8. So up to this, I am stopping here. So thank you everyone. Good night and meet you again in the next class. So thank you. I'm stop this meeting now.